about the topic is about application of titration in food and beverage industry. So what is titration? So titration is a chemical method used to measure the exact amount of a substance in a solution. It involves adding a reagent called a titrant until a reaction is complete, usually indicated by a color. Let's look at a real-world use. Titration is used to control acidity in juice, measure salt in snacks, check preservative level in canned foods, and monitor minerals in milk and wine. A common example is measuring citric acid in orange juice. By titrating with sodium hydroxide, manufacturers can ensure the juice tastes fresh and meets acidity standards. So why is titration is important in food and beverage? First is can ensure consistent flavor and quality, confirms correct ingredient concentration, and support food safety and labeling compliance. Another that, titration offers several benefits. It's fast, cost-effective, and highly accurate. That's why it remains a trusted method in food laboratories around the world.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Indra Haziq bin Muhammad Adillah. Now, I'm going to talk about theory and application of titration in food and beverages industry. So, acid-base titration is a method used to measure how much acid or base is in a solution by reacting them until they neutralize each other. In the food and drink industry, this technique is important for checking and controlling the acidity in products like vinegar and fruit juice because it affects their taste, shelf life, and safety. It's simple, accurate, and affordable, making it an important tool for checking product quality and safety. So, what we can see here, we go into theoretical background in application of titration in food and beverage industry. So, we have principle of acid-base titration. It means an acid reacts with a base in a stoichiometric ratio to form water and salt. Acid plus base form salt plus H2O. The concentration of the acid in the sample is calculated using C1V1 equals to C2V2, where C1 is concentration of acid, V1 is volume of acid sample, C1 is concentration of base titrant, V2 is volume of base used. And we're going to isothermal titration calorimetry, or known as ITC. So, purpose of ITC, isothermal titration calorimetry, ITC, is an advanced titration technique used in the food industry to study how small and large molecules interact in food and helping to understand food quality. And then, structure of the calorimeter. The isothermal titration calorimeter consists of two cells, a reference cell and a sample cell, inside an insulated jacket with temperature differences detected by thermocouples. Next, unique feature in ITC. ITC is unique because it directly measures the heat change or enthalpy during molecular interactions, which no other technique does. And lastly, how the ITC process works. During the process, a ligand is titrated into the sample cell containing the micromolecule, and the calorimeter records the heat changes to analyze molecular interactions. Thank you.
The objective of titration is to determine the concentration of specific substance such as acid, base, and salt in a food or beverage sample using titration method for quality control and compliance. The reagent preparation that being used is such as NaOH for acid titration and HCl for base titration. This is to use accurate concentration known through primary standardization. For indicator chosen, we can choose phenolphthalein for acid base, which is strong acid or strong base, or weak acid to strong base. And next, we can choose methyl orange for strong acid, weak base, and titration. We can also use digital pH meter for a more accurate result. The next one is for the procedure of titration experiment. A measured volume of the sample was pipetted into a conical flask. Then, a few drops of indicator were added. This is if a pH meter was not used. The next one, the sample was titrated with the standard solution from a burette while swirling, and the titration was stopped when the endpoint was reached. This is indicated by a color change or stable pH reading. Lastly, the volume of titrant used was recorded. After the experiments was done, we can calculate the concentration of analyte by using the titration formulas, which is M1V1 equal to M2V2. For quality assurance, repeat the titration at least 3 times for accuracy, use calibrated equipment, and maintain clean glassware to avoid contamination. Here are some examples for food and beverage that we can use for experiment, which is fruit juice or soft drinks. We can use butter or cheese, wines, and juice.
Example of the data. Result of titration experiment citric acid in orange juice. Objective: to determine the concentration in mole per liter and gram per liter of citric acid in a sample of orange juice using acid-base titration with sodium hydroxide. Material used: 25 ml orange juice sample, 0.100 molarity sodium hydroxide NaOH solution, and phenolphthalein indicator, burette, pipette, and conical flask. We can see this presentation, they show the titration data, and then calculation. We use the formula MA multiplied VA equal to MB multiplied by VB divided by N, where MA is molarity of citric acid unknown, VA equal to volume of orange juice 25 ml equal to 0.0250 liter. MB is molarity of NaOH equal to 0.100 molarity. VB volume of NaOH used equal to 20.20 milliliter equal to 0.202 liter, and N equal to 3 because citric acid is triprotic. After calculation, we get the final result concentration of citric acid equal to 0.0269 mole per liter, and mass of citric acid equal to 5.70 gram per liter. This means every liter of this orange juice contain 5.17 gram of citric acid. This value is within the typical range for commercial orange juice for until 7 gram per liter. Ensure proper flavor shelf life and acidity for quality control.
Hello, my name is Muhammad Aiman bin Muhammad Jafri. Now that we have seen how titration works and how we did it in our experiment, I will be sharing the conclusion. So, why is titration important? Well, titration is a very useful and trusted method, especially in the food and drink industry. It helps check things like how sour a juice is, how sad a snack is, or how much preservative is in a soft drink. This makes sure the food and drink we enjoy are always safe, healthy, and taste the same every time. It also helps companies follow health rules and avoid mistakes. For example, if something is too salty or has too much acid, titration can help fix it. By using titration, company can make better decisions, reduce waste, and keep their customer happy and safe. Okay, in our experiment, we saw how titration helped us measure something exactly. When we added the liquid slowly and saw the color change, that taught us we reached the perfect amount. This shows that titration is not just for big factories, it is something we can do in the lab to get accurate results. In the end, titration help us understand what is in our food and drink and make sure everything is made just right. Okay, thank you.